Our story begins roughly 4.6 billion years ago, not with a bang, but a colossal cold cloud of interstellar gas and dust, a solar nebula.
Triggered by a nearby supernova shockwave, gravity began pulling this diffuse material inwards. As matter condensed, the central region grew hotter and denser, marking the inception of our star.
As the cloud collapsed, it flattened into a vast, rotating protoplanetary disk. The majority of the material coalesced at the center, destined to become our star.
When the central mass reached critical temperature and pressure, nuclear fusion ignited. Our sun was born, blazing to life and emitting a powerful solar wind.
Within this disk, microscopic dust grains began to collide and gently stick together, a process called accretion. Over millions of years, these tiny particles grew into pebble-sized clumps, then boulders, and eventually small rocky bodies called planetesimals. The powerful solar wind pushed lighter gases and ice away from the sun, leaving a frost line. Inside this line, only rocky materials could survive, while beyond it, both rock and ice were abundant.
In the hotter inner regions, planetesimals continued their violent collisions, gradually accreting into the terrestrial planets. Our homeworld was forged in this fiery, cosmic dance.
As the collisions continued, the largest bodies grew at the expense of the smaller ones. Through this process, our proto-Earth grew, becoming the dominant body in its orbit.
Further out, beyond the frost line, icy cores were able to grow to immense sizes. Once they reached about 10 times the mass of Earth, their gravity became powerful enough to attract and pull in vast envelopes of gas. Over millions of years, these cores rapidly accreted huge amounts of hydrogen and helium from the disk, transforming them into the majestic gas giants Jupiter and Saturn. Their formation shaped the rest of our solar system.
Jupiter's colossal gravity played a crucial role in shaping our system, clearing out dangerous debris and protecting the inner planets from countless comets and asteroids. The remaining planets, Uranus and Neptune, were formed slower, farther out. They also grew large enough to become ice giants, but they had less time and less material to pull from the disk before the solar wind cleared it away. The powerful gravity of Jupiter prevented a planet from ever forming between Mars and Jupiter, leaving behind a collection of rocky remnants in what we now know as the asteroid belt.
Beyond Neptune lies the Kuiper Belt, a vast, donut-shaped ring of icy bodies, a cosmic graveyard of frozen material left over from the formation of the outer planets.
And even further out, an immense spherical cloud of comets known as the Oort cloud surrounds our system. This is the last remnant of the original solar nebula, the final testament to our system's turbulent birth. And so, over tens of millions of years, our solar system took shape. From a swirling cloud of dust and gas, an elegant, dynamic system of planets, moons, and countless smaller bodies emerged, a testament to the powerful forces of cosmic creation.